Hey everybody, it's Mr. Bronze, aka Big Daddy B. Just sending you this video because I have a feeling what I've been sending in may not be resonating very well with you all since I am not there. In case you haven't heard, I've been home because I tested positive for COVID and I am symptomatic, so I haven't been feeling well at all. Um, Certainly not at the end of the road by any stretch of the imagination, but and there are plenty of people who are better off than I am, but definitely not feeling that great. Like having a super bad sinus infection and really exhausted all the time. So, what I decided to do is put this little video together for you. This video is going to be from the assignment that I left for you on Friday. It's Sunday at 6:16, and I didn't see many people submitted it electronically. I don't know if maybe you were expecting me to be in and you had questions, whatever it might be. So I thought it might be a great idea to go through it with you. So what I would like you to do now is, if you haven't done so already, I have attached a clean file as both a PDF doc and a Google Doc. So you can pull up on whichever one you want. Probably the PDF file would work better if you're going to work in Cami, because we are going to be drawing on our diagrams. So if you need to pause the video for a minute, please do that now while everyone gets their files open. All right, so everyone's got their file. And basically, what we're going to talk about today is working backwards from what we have been doing with the normal model. So for our normal model, we've generally been working with values that we've been given. For example, we might be told that the average SAT score is 1,000 with a standard deviation of 150. And we're asked for the percentage of students taking the test that score below an 800 or above a 1350 or between 1,000 and 1,100. So we're given all these different values to work with. And we used normal CDF in the calculator to work with that. What we're going to explore today is using the next function listed right underneath that in the calculator called inverse normal. So before we go any further, hopefully you can see this all right on the screen. So I've got my calculator here in the middle, and this is the emulator I was able to download on my computer so you can see what I'm doing. If you press your second bars key, this is the typical menu we've been in, and we've been using option 2, the normal CDF. If you choose 3, inverse normal, this is what the new function that we're going to be working with. Okay, so I just want to show you where it is first before we get started. So that's second, vars, and then number 3. Okay, so let's look at this first question. We want to label the normal model, shade the appropriate area, and find the z-score cut point for the lowest 40% of the distribution. So first of all, what is a z-score cut point? A z-score cut point, you may want to add this to your notes, is a z-score value that marks a point where a specific percentage of your data falls below or above that value. So it sounds pretty fancy, but all it is basically a z-score number where there's a certain percentage of the data to the left of it and a certain percentage of the data to the right of it. Now, for every question, that percentage is going to change. If you notice, for this question, we're asked for the z-score cut point for the lowest 40% of the distribution. So the first thing we're going to do is we're going to label. Now, there's really not too much to label here because we don't have a mean. We don't have a standard deviation. As a matter of fact, the only number we know is that we're looking for the lowest 40%. So we've been planting a flag on our normal distribution models where we put this vertical line segment. Now, we want to find a cut point. So we want to know where we are here on our axis. What is our z-score on our axis? So that the lowest 40% of the distribution will fall to the left. Well, don't draw this in yet. Just want to show you real quick. This is right down the middle. If I was to plant my flag here, that would mean 50% of the distribution is to the left and 50% is to the right. And we know that because the normal model is symmetric, about the mean, dead center. But we don't want the lowest 50%. We want the lowest 40%. So that means we're going to have to drag our flag to the left. Now, we don't know exactly where. That's okay. So we kind of estimate. I think maybe it's about here. Okay, the estimate isn't important. The important is the idea is we know that this cut point falls to the left of where our mean is. And we might want to mark our mean. Why don't we go ahead and do that? I apologize if this constant coughing and throat clearing is annoying. Just comes with the territory right now. All right, so here's our mu, here's our mean, dead center. We're estimating that our z-score cut point, and that's the number we're looking for. We're looking for a z-score. It's going to be right here where this vertical line is. And we're indicating that 40% of our data falls to the left of that. So let's go ahead and also mark that. Let's put a 40% here. 0%. And we can shade this a little bit too because we're used to doing some shading to represent the side that we're finding the area of. Sorry, I'm coloring like a kindergartner here. Excuse me. Okay, so in actuality, that is all we can do as far as labeling. We've put in our, we've planted our flag, we've represented our percentage to the left, and we've shaded what side we're looking for. Now we're going to turn to the calculator. And remember, we are going to use inverse normal. This is how it looks on the calculator, inverse norm. And inverse norm, when we select that option, asks us for a couple of things. And it starts with area. Okay, and as you can see here, so if you haven't done so and you turn your calculator on, hit second, vars, choose number 3. And I'll do it one more time just to show you up here. Second, vars, number 3. So here I am, inverse norm. So first question is, what is the area that we're looking at? The area is always to the left of your flag. So what we're going to write down here, we're going to do kind of like some, like a cheat sheet almost. When we get to inverse norm, we want the area to the left of our flag. That's the first thing that we're going to enter. We know for this particular question it's 40%. Now we also know that with our calculator, we enter percentage as a decimal. So our area should be, hold on. There we go, 0.40. So right underneath we see mu, which is our mean. We're going to leave that as 0 because remember we want a z-score. And we have a z-score. That means we've standardized our values where our mean is 0 and our standard deviation is 1. So we're going to leave the 0. We're going to leave the 1. We're going to highlight paste, press enter, and press enter again. And there's our z-score. So before we write that down, let's finish our cheat sheet here. So we put the area to the left of the flag, then 0 for our mean, and 1 for our standard deviation. So this is going to be how we enter in our values when we are in search of a particular z-score cut point. So, sorry if my voice is getting a little low. Our z-score cut point means we found the probability that that the area is less than 40%. So remember, when we're talking about area, it's our normal curve is a dartboard. You're throwing a dart, and there's no way you can miss. What is the probability that you're going to hit this blue shaded area? And our calculator told us that it was about negative 0.25. We use 2 decimal places. So we've got negative, and we're going to put a 0 in front to be here. We don't want to just leave that decimal hanging with no ones place. And there we are. So I know I gave you a bit of a long explanation, but I want to walk you through it. So the probability of hitting this area, our z-score, okay, that's our z-score value. And you know what, let's change that. There we are. So the z-score of 0.25, okay, 0.25, negative 0.25. All right, let's try the highest 30% of the distribution. So again, no mean, no standard deviation. We start with planting a flag. And we're not going to plant it here in the middle. This is just where I'm starting from. Here's where 50% to the left and the right. I want 30%. I want the highest 30%. So I want to slide to the right because now I only want 30% of my data to be over here. So I'm going to go in. I'm going to label this 30%. There it is. So this is the region we're talking about. Now, we know it's 30%. What we don't know is what is this number here? What is our z-score that's going to put us there? Now, we already know we're going to use inverse normal. So that's fantastic. What we have to remember is inverse normal wants to know, excuse me, what is the percentage in this area? All right, the percentage to the left of our flag. That's what we need to know. So since the percentage is 30% here, we don't use 30%, we use 70%. And we've already got our labels all together. So now we know we're going to use inverse normal, our 0.70. Then we're going to put 0 for our mean. We're going to put a 1 for our standard deviation. And see what that gets us. So again, second, bars, inverse normal. Instead of 0.40, putting 0.70. It's going to go down to paste, enter, enter again. And in this case, we're going to get 0.52. That equals 0.52. That's our answer. That is our cut Z score. Okay. So hopefully you're seeing, what the parameters are for a problem like this, what the steps are. Again, let me review. You're going to set your flag, approximate where you believe it to go based on the percentage that you're given. We want it highest 30%. That means 30% is to the right. We always have to figure out the percentage to the left because that's the way our calculator is programmed. We have what we call a cumulative function. So we start from the left. So we subtracted 30% from 100 to get our 70%. From there, inverse normal, 70%, 0, 1. All right, let's take a look at the next question. How about the middle 30%? So we did a left side, we did a right side. Now let's do a middle. So here we got to think a little bit. We want to remember that. And again, don't draw this line in. This is just a starting point to think about. Right here is dead center. Now I want the middle 30%. So if I take 30% and I divide it by 2, that means I want 15% on each side of where my mean goes. My mean is right in the middle. So I'm going to clone this little guy here. So I have 2 of them. And I'm going to estimate where 15% is to the left and 15% to the right. There we are. And again, I'm just guessing. More importantly is the visual. All right, maybe you think it's a little bit bigger. Okay, so open it up. It's really your choice. What you can't do is make something ridiculous and put these lines way out here to the right and the left and try to convince me that's the middle 50%. We all know better. The middle 30%, excuse me. So let's label it 30%. Okay. Make that bold. All right, so now we're ready to go. Let's go ahead and just shade that in a little bit because we know we're working in the middle. All right, so now the question is, how do we figure out z-scores? Well, we're going to need two z-scores. Not only that, we're going to need some to figure out some percentages. Okay. So, excuse me. So we've got 30% in the middle. Now we also said, let me drop a dotted line here just for a sec. We also said that our normal distribution is symmetric. You don't have to draw this dotted line. I'm putting this here to reinforce the idea that for our 30%, that dotted line splits in half. That means 15% there, 15% there, which is important. Why it's important is this dotted line represents the halfway mark. So 50% of the data is to the left. If 15% is here, I can take my 15 and subtract it from that 50. Come on. I don't know why my marker's not working all of a sudden. There we go. Well, it works when it wants to work. So if we take 50, 35% left over. It's over here is 35%. So why is this helpful? Well, this is helpful because we need this cut z-score right here. And that's where we're starting. Then we'll get the other one when we're done. So basically we have two problems rolled into one. I know this is 35%. So that means that's the percentage to the left of where x is. So now I can go to inverse norm, use my 35%, 0, and my 1. And that'll get me my z-score that I need. Go ahead and do that. Second, bars. Inverse normal. My area is 0.35. Okay, go down to paste, enter, enter again, negative 0.39. So we got negative 0.39. Sorry, I just had to reach for my calculator. Negative 0.39. So that's the first one. Done. We have the second line here. So I'm going to do inverse normal again. Now we're going to have a different percentage. Move this down a little bit. Let's say that the z-score, this cut z-score here is y. So now, what is the percentage to the left of this line? Well, we could add 35 and 15 and 15. That would be one idea. Or you could remember that the dotted line splits it in half. So everything to the left of the dotted line is 50% plus an additional 15. Either way, you're going to recognize that to the left of where y is 65%. So once again, go to the calculator. So second bars, number 3. So now I got a 0.65. There we go, 0.65. Go down, 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 paste, enter, 0.39. So now I've got 0. So now the thing is, here our z-score isn't a single value. We want to know where the middle 30% is. So we need to use both of these z-scores. So when we write our answer, we can say middle 50% is, and then we can show it as an interval. So it is in the interval. So on the left side, it's negative 0.39. On the right side, it was positive. And we're looking for a z-score, so we put z in the middle. Space is held better. They are. Okay. In the middle 50%. Hopefully everybody's doing okay with this so far. All right, so we'll do one or two more together with you guys. There we go. Practice number one. Suppose a college says it admits only people with SAT verbal test scores among the top 10%. How high of a score does it take to be eligible? Okay, sorry, technical difficulties here. Shouldn't put that shade up. There we are. So I'm just going to pause for a second here. Okay, there we go. Sorry about that. So in this particular question, I inadvertently forgot to give you the mean and standard deviation. That's why I paused the video. I thought something was a bit odd. So what I had done was in a previous lesson, we had done a question with SAT verbal scores, and I expected to do them together, but whatever. So here we are. We have a normal distribution, mean of 500, standard deviation of 100. So remember, I get to you in notation form as a reminder that we don't always get these values given to us written out in a sentence. So remember, n tells us that we have a normal distribution. Our first value is our mean, and our second is our standard deviation. All right, so why don't we go ahead and label diagram. So we'll have 500 in the middle, 4, 3, 2. So this would be 200 way down here, left end. And then we're just going to keep going. So we'll use Cami, whatever else it might be. It can be easier just to start away on the left and go to the right. I'm going to pause the video again. All right, hopefully we won't have to pause anymore. I've isolated myself in my finished basement in my house. I'm going to set up a little bed for myself, but I'm over by the oil burner. I had the door open and it turned on, so it sounded like I was next to a jet engine there, so I apologize. All right, here is our layout so far, me in the middle, standard deviations of 100. We want to know what is the score that a student would have to get into this college. The college says it admits only people with SAT verbal test scores among the top 10%. So let's plant our flag for an estimate as to where we think 10% would be. So top 10% implies the 10% to the right of where our flag is going. I'm going to put mine here. Okay. So that means I've got 10%. Highlight my 10%. A little bit bigger. Okay. Make it bold. Actually make it a little smaller so it'll fit nicely right in my little spot here. So you guys should be doing the same. And not much room to shade. We'll go ahead and shade a little bit. And there it is. So as we said earlier, using this new inverse normal, we want the percentage to the left of our flag. So that means if there's 10% to the right, it's 90% left. That's what we're going to need to use. So calculators. Small. Now we're going to put in 0.90. Now here's where we do things a little bit differently from the previous question. In the previous question, we were looking for z-score cut points, just z-scores. Now we want actual values. We want a score. So now we have to enter the mean, or mu, which is 500, and our standard deviation, 100. So changed it up just a little bit. So let's do it. We got 90%, 500, 100. Second, bars, number 3. So 90%, 500, 100. Enter, enter. And there we are. So we needed to score of 628 or better. So let's bring this back over. Actually 628.155. So let's think about this for a minute. Or 0.16. We've been working with two decimal places. So obviously we can't get a decimal score on the SAT. So actually 628 would be too low. Okay. So to be eligible, takes a score of at least 629 into college, because 6 would be too low. So even though, remember, we talk about this typical rounding, algebra rounding wouldn't round up, but in the real world, often we do. We round up, even when it's not a 5 or greater in that next position. Okay, hopefully you guys are starting to get the idea here. So what I'm going to do is I'm going to leave the last couple of questions for you to finish up this period, if you hadn't done so already. I've talked long enough, and actually, my throat's killing me. So, hey, and there's Ricky Henderson. Hello. Hopefully, you guys are getting along okay. Again, I'll be in, I think, Thursday. I'll be returning. So we'll be hanging on until then. I don't know if I'm going to make another video between now and then. I just thought it was important at this point to get one out to you guys. So we'll see how it goes. All right. So everyone, make sure you're doing well, staying safe, and I'll see you in a few days. Take care, guys. Bye-bye.